All right, hello and welcome to another edition of the Trino meetup. Today we are joined by Yixuan Huang from Robinhood, who's going to tell us about scaling Trino at Robinhood, which is going to be super interesting. I'm Manfred Moser. You might know me from the Trino community broadcast. We're hanging out once a month, me and Brian, talking about latest things. Just last week, we in fact talked about open sourcing the Delta Lake connector to Trino. So if you missed out on that, do jump in to our show notes and the video of recording of that. I'm also joined by Neetu Goswami today from Starburst. She knows all about Trino and Starburst as well, so she's going to tell us a bit more about that. And with that, we're going to roll right into our meeting, into our meetup. So operating Trino at scale at Robinhood today. Just a few updates. I already mentioned the Trino community broadcast was happening last week, and all that is live. Then we will talk about Trino and Starburst a bit more. And then Xuan is going to tell us all about Robinhood and their usage of Trino at a pretty impressive scale. First of all, let's talk about community, a few things. As you know, the Trino community is very active. We have the Trino community broadcast, trino.io/broadcast, with the latest episodes also available. You can rewatch all the episodes and so on. And then, of course, if you have any questions, you can join us on the Trino Slack channel, where we have separate channels for beginners, for different projects like our project tardigrade, or just even jobs or questions for development, contributing, and so on. So make sure you join us there. You will be not alone, and there's no such thing as a wrong question. There's over 6,000 people at this stage hanging out regularly and tossing all sorts of ideas and collaboration around, and you will be most welcome to join us there. Of course, you can find me and Vishwan and many others there, all the maintainers, contributors, and so on. In addition, we run regular Trino virtual meetups like this one today. We also do them for the EMEA region as well as for the Asia Pacific region. Contributing to the project is always welcome. Open source is what we live and breathe. So in the Trino.io website /development, you can find out more. You can also find out us in terms of source code on GitHub, TrinoDB/Trino. And please do make sure you star us. You see the URL down here. This is the documentation. We also have videos on how to add documentation. So contributing is not necessarily requiring you to know lots about Java and whatever. Maybe you just need to read the docs and find a spelling mistake. So help us out. We would love to hear from you. We also like to get your questions on the Trino forum. So Trino forum website, linked on the Trino website and other places, where you can ask questions, get knowledge beyond what's available in the documentation and on the website. And you see here, various people are chiming in, asking specific questions and getting lots of useful answers. Last but not least, thank you very much for joining us. As a little thank you from Starburst, we are more than happy to send you a t-shirt similar to this one. The one over on the screenshot here has the Commander Banban, even bigger without the space. Feel free to look at the chat for the inform and URL and request one of those cool t-shirts to show off Commander Banban and your commitment to helping the Trino community and being part of the community. With that, make sure during our broadcast today, we do take questions all the time. You can add them on LinkedIn chat or YouTube chat, and also on Slack. We'll have a look on there as well. And I will be answering or trying to funnel the questions toward Yixuan to actually answer the questions later on today. With that, I will switch over to Neetu to tell us more about what Trino is and what Starburst plays a role in the world of Trino.
Absolutely. Thank you so much for that, Manfred. For those of you who are joining us for the first time, welcome, welcome. I am very excited to be a part of this open source Trino community, and we're always looking to add more people to it. So if you know anyone that's using Trino, please do invite them to these open source meetups. We've had a great opportunity to talk to companies like Robinhood, Shopify in the past, EA Games, and they're always sharing best practices and their practices of how they're using Trino and how they're scaling Trino in their own environments. But today I'll be talking a little bit about Trino, and then I'll be switching gears to Starburst. My name is Neetu Goswami. I actually do work for Starburst. I cover all of East Coast for data native organizations that are leveraging data at a very high scale. And using that for downstream use cases, whether it's internal analytics or ML AI use cases or reporting use cases. Okay. So let's start with what is Trino. Trino, as you all know, formerly known as Presto SQL, open source distributed SQL query engine. It was created by Martin Dane David when they joined the Facebook infrastructure team in 2013. So Facebook, as we all know, had massive army of data users, and they had a massive Hadoop cluster, and they couldn't scale their queries. That's where Martin Dane and David actually created Trino or Presto SQL. So Martin Dane David are actually the founders of Presto or Trino, still 100% committed to Trino, and the top contributors of both projects and founders of the Trino Software Foundation. So what is Trino? What are some of the challenges that Trino is solving for various organizations all over the globe? It is a high-performance MPP SQL query engine, mostly used for reporting or interactive use cases or auditing use cases. It is proven, for scale as well as high concurrency. As you can tell, created at Facebook, they definitely needed that scale. They needed that high concurrency. So definitely a great SQL MPP query engine. But most importantly, it kind of decouples that compute and storage, which is very important for, cost efficiencies, right? So you do get that scale of kind of like, from the data lake, but kind of with that MPP SQL query engine, you get the performance that you need to scale your reporting or ad hoc analytics use cases. Another good thing is you can pretty much SQL on anything. Because of the ANSI SQL capabilities, you essentially can tap into different sources and federate your queries as well. So very, very proven for scale, federated queries, and high concurrency, which is helping a lot of our customers. Or Trino customers. Again, open community, open source community, which is like Manfred was mentioning, there are about 6,000 people who are constantly, contributing to this open source community and adding more and more things that that is helping organizations. But you can essentially deploy it anywhere, either on Kubernetes, on cloud, or on premises. So that's a little bit about Trino. If you have any questions, definitely feel free to drop in your question, but I'm going to switch gears and talk a little bit about Starburst. So if you have actually started using Trino and you're kind of thinking about what is this enterprise version of Trino Starburst, we essentially offer two types of deployments. One is the Starburst Enterprise. Again, it's more for, if you have legacy data in on-prem sources, as well as a little bit of data has been moved to the cloud, migrated to the cloud, and you're looking for something to tap into or federate those queries for better insights and scale that, then definitely Starburst Enterprise is a great option. Why you would actually switch from Trino to Starburst is because of that enterprise performance, right? The auto-scalable clusters, the graceful shutdown. It has given a lot of customers massive cost efficiencies because you don't have to do that manually. It's a managed platform, so it kind of takes care of that for you, as well as I think massive data team productivity gains, right? Security is another big one because of the inbuilt Ranger. We do provide that security out of the box. Connectivity, you do get additional sources that you can tap into, and 24/7 support by the Trino experts. So that's one of the reasons why you would actually switch from open source Trino to Starburst, which is the managed version. But we've just recently announced the Starburst Galaxy offering as well, which is completely SaaS. It's cloud native. So if you have some sources like a data lake and other sources that are in the cloud, and you want to essentially tap into them. It is a new offering, so we don't have a lot of the popular connectors, but we're always working on that, and we do have a roadmap. Happy to share that with you. But yeah, fully managed. You can tap into your cloud sources and get everything that we talked about in enterprise. Okay. We've been selling as Starburst for around last 2 years now, and we already have 150 enterprise customers, almost $500 million raised from very impressive, different types of organizations that you can see over here. But it provides you with that enterprise-grade Trino, ensuring scalability, security, performance, and that enterprise-grade, best-in-class 24/7 support that we're providing for our customers. Okay. Where we actually fit in is right in between the tools that your data users are using. So whether it's the data science data users, they're using Jupyter notebooks or Spark or any of those specific tools, and BI analysts, if they're using Looker, Tableau, ThoughtSpot, any of those BI tools, between the tools they use and the sources they need to fetch the data from. So we kind of sometimes are called semantic layer, query fabric, consumption layer. You essentially continue using the tools that you're using, and Starburst does all the heavy lifting, getting the data from different sources and providing you with that enterprise-grade security. So role-based access control, row-level, column-level security is kind of all built in. And it provides you with that unlimited scale, concurrency, and that security that I talked about. Okay. With that, I'm always available on LinkedIn. If any of you have any questions about Starburst, absolutely happy to connect. I will be passing on to Yeshwan now to actually share with us how they are operating Trino at scale at Robinhood.
Okay. Hi, everyone. My name is Yichuan. Thank you, Manfred and Nitu, for the introduction. And today I will be sharing how do we operate Trino at scales at Robinhood. So first, a quick glance at how do we use Trino in Robinhood. So we use Trino as the underlying query engine for our query platform. The use cases are we have experiment analysis, we have data analysts that run queries against our data lake, and we use Trino for incident response and also for dashboard reporting. As for the numbers, we have an average of 300K plus queries per day, and which sort of corresponding to 3 petabytes plus data per day, and the numbers that keep growing. And now we have, currently we have Trino, 7 Trino clusters, and each Trino cluster has 50 to 100 nodes per cluster, and we have around 700 daily active users, and the number is also growing. So yeah, so Trino is definitely a very fundamental pillar in our data platform team, and which is supporting our Robinhood company as well. So this is a 10 feet high-level overview of how our query infrastructure look like. So on the left side, you see there are users submitting queries through different clients. To name a few, we have JDBC clients like Looker and Alation, and we also have Python clients like Jupyter Notebook and some other services, some other ad hoc services. And also, plus we also write some customized Trino clients in other language to support different use cases. On the central area, there's a query gateway here. It stands in the central to take user queries and submit the queries to the backend Trino clusters. So this is a project released open source by Lyft. It acts as a load balancer, also a proxy, a gateway layer, and also an authentication system for our Trino query engine. We'll talk about that later. So on the right side, we have multiple data sources that are connected to the Trino cluster. We have Hive, which Hive is the metadata layer, and internally, all the data were persisted in AWS S3, which is our data lake. The Hive queries are serving as like I think over 90 or even 99% of the usages. And we also connect Trino to RDS replicas, to Google Sheets, and also we have ongoing projects of embedding Apache Pinot to our tech stack, which is also integrated to the Trino clusters. So next, I'm going to dive deeper into how we operate Trino. First, I'm going to talk about worker machine type selection, few big versus many small. So previously, we have a many small kind of setup. By that, I mean we have 200 plus workers per cluster. And each worker is using a small AWS instance type, i3.4x large, which has 16 CPU and 128 GB of memory. With that, we saw some limitations and issues. So first, we have to set limit on configuring the maximum memory per node, and since that can easily be exceeded by some medium-sized queries. And we have, since we have many workers, we have too much data exchange over network, which causing the performance to be bad, and causing some timeout. And also the other issue is we started seeing open file descriptor limit issues when trying to scale up to 300 workers. And even if we follow the instructions to tune that number to the maximum number we can set, which is 500K or something, 500K plus, but still we are seeing that issue. So we did some research, and we saw on Starburst, one of the Starburst YouTube video was recommending that to use few bigger instance type to replace the many small setup. And the benefits of using few bigger machines are including but not limited to that the node scheduler, which always usually node scheduler runs on the coordinator. It allocates tasks more easily with fewer nodes because it has the less metadata information it needs to compute, like which node to send the task to, the faster it can make decision. And also, bigger machine means we can handle data skew way better. That because bigger machine have more cores for parallel join, and also it can allocate more memory for hash table for establishing prop tables. Also, fewer machine means less overhead for broadcast joins and less data exchange between workers. And the other thing we set with a few big instead of many small is that we maintain the total amount of resources meaning total number of CPU and total number of memory, but we can get better performance because of the previous the above bullet points, and that allows us to basically to get better performance, but at the almost similar total cost. So we did some query analysis against our query logs on different usages. We have two main Trino clusters. One is ad hoc. One is serving ad hoc usage. The other is serving ad hoc usage with PI data. So what we found was that over 93% of the queries for ad hoc usages were finished within 1 minute. And the P99 peak RAM for those queries was 238 gigabytes. And for ad hoc PI usage, over 99% of the queries were finished within 1 minute, with P99 peak RAM only 6 GB, which means our ad hoc usage has more moderate memory requirement, while the ad hoc PI usage does not. So the next step was to choose which instance type to use. So after some evaluation, we chose R5.16XL. and apply it to all the clusters, since several reasons. One is it scales up proportionally, which basically is 4x the total number of resources against i3.4x large. And it has a good balance of CPU and memory. So we basically just 4x the vertically 4x vertically scaling the instances to make sure our queries are all running fine in that condition. And then we also compared running the same batch of queries on the old setup, which means the i3 4x large versus the new clusters. And we actually get much better number in the new cluster. The other implicit reason for choosing this instance type was our contract with AWS allow us to have a good discount on the R5 instance family. So that's another reason. One of the things to do here is to better tailor the instance type for use cases like ad hoc PI. If you remember the previous slide I'm showing, ad hoc PI depends less on the memory, but it's more compute extensive, so that we can. So currently we are using R5 16XL universally, but in the future we want to select more like have maybe like select a computing extensive instance type for ad hoc PI usages for both better performance and to save cost. So this is some stats against the comparison between the old setup and the new setup. So we handpicked 1 hour of our ad hoc queries and submit to both the old cluster, which is 200 i3 4XL instance, and the new cluster, which is 50 R5 16XL nodes. So on the right side, we can see the new cluster has a much smaller P90, P75, P50 execution time on all the queries, and it runs faster in more queries than the old cluster. If you see here the red boxes, that number of queries with shorter execution time compared to the other. So the new one has 852, and while the old one only has 485. And we actually see a higher maximum execution time and P95 execution time in the new cluster than the old one. The reason was that we had a couple of queries that exceeding the maximum memory per node limit on the old setup, while it doesn't fail out on the new clusters. That's why, because those queries just finished in the new cluster and they failed in the old cluster, which contribute to this high execution time, a larger execution time. And yeah, like we also, as I mentioned, we also are seeing a higher success rate in the new cluster, which is 93%, than the old one, which is close to 91%. Next, I'm going to talk about auto-scaling for the Trino clusters. So we have traffic peak traffic time and low traffic time. So we want to adapt our clusters to fit in to adapt to the traffic pattern. And since we are using AWS autoscaling group to set up all the Presto workers, all the Trino workers, sorry. ASG autoscaling group natively supports scaling based on CPU utilization. So we would just benefit from that. And we chose the simple scaling strategy. So we have both upscaling and downscaling policies. Upscaling policy is add 50% of the nodes when utilization is over 80% for the last 5 minutes. Downscaling is reduce 1/3 of the nodes when the utilization is below 30% for the last 2 hours. And the reason for, more frequent upscaling check was in case of traffic surge, we want to guarantee our cluster can hold all the queries. And we don't care that much if downscaling lags a little bit. So another important prerequisite for this for downscaling feature is that we have to turn on gracefully. We have to enable gracefully shut down the workers to avoid running queries being killed during downscaling. Since otherwise, by default, Trino workers will just shut down itself and kill all the running queries. And we have this 1 hour AWS instance timeout to allow graceful shutdown. So this is basically a graph showing how we do the Trino autoscaling. On the left side, it shows how we do upscaling. It's pretty simple. Basically, just high CPU. Whenever there's a high CPU alert on the last 5 minutes, the ASG will trigger upscaling to add more instances to the Trino cluster. For downscaling on the left side, so if the condition is met, then it will. We also configured lifecycle hook in the ASG that ASG will trigger a downscaling event, and we have our own lifecycle service to capture that event and send the graceful shutdown signal to the Trino workers. And then the Trino workers will just start gracefully shut down the shutdown itself within this 1 hour timeout. So things to improve. We still have a couple of things to improve on the autoscaling setup. First is CPU might not be a good indicator for memory-intensive clusters. But since ASG doesn't come with native support for memory, we can actually build our own custom metrics to trigger the autoscaling events. We had done that for our Hadoop cluster setup, so we can copy the same. We can basically just replicate the same stuff here. Another point is queries couldn't finish within 1 hour, could still be killed during downscaling because of this the 1 hour shutdown timeout is hard-coded. And the solution to that is, again, we also have that in our Hadoop cluster setup, so we can replicate the logic here. We can build this adaptive decommission service, basically to do stuff like it will keep listening to the lifecycle service I just mentioned to trigger the worker graceful shutdown upon downscaling signal, and keeps polling the worker status until the worker is being inactive or decommissioned, or basically the network connection to the worker is lost. Then also, if the worker cannot finish gracefully shutdown within 1 hour, it can send another event to ASG telling it to extend the instance lifecycle if necessary. The maximum allowed extension is 48 hours, so which is way more enough than what we need. And finally, if the worker successfully gracefully shut down itself, then we trigger ASG to shut down the instance. And also, there's one issue with this simple scaling strategy that upscaling could be blocked when downscaling is happening. So even if there's traffic surge and the CPU usage is higher than 90%, upscaling is totally blocked. This could happen. So instead of doing simple scaling policy, AWS actually recommended us using the step scaling policy, which brings us 2 benefits. One is to unblock the upscaling. The other is we can have more tiered level downscaling policies. For example, like previously, we only do downscaling when the usage is below 30%. Now we can say if it below 50%, we can downscaling say 10% of the nodes, and if it goes further down to 40%, then we bring down another 20% of the instances, etc. So this is a simple graph showing how this decommission service works. So ASG trigger lifecycle event, the hook captures it and sent to the decommission server, which is running on the coordinator. And then it's going to be a single service. And then whenever it receives that, it sends to the worker to trigger a graceful shutdown. And in the meantime, it keeps communication with ASG to either extend or terminate the instance. Next, I'm going to talk about high availability setup for our Trino clusters. So the problem with single cluster that Currently, I believe there's no native HA solution for Trino coordinator. And I know that Starburst have provided standby coordinator as a hot backup if the master coordinator fails. But then the issue with that is it cannot save the running queries. So meaning that if you have queries running on the active clusters, even if it fails over to the other coordinator, those running queries will still fail. Also, single cluster has scaling limit. Like I mentioned before, we met with this open file limit issue when we have 300 workers, which with 200 running queries. And there could be heavy queries clogging, several heavy queries that clogging the whole cluster that blocks other queries, other simple queries as well. And there could be downtime during cluster maintenance, like regular churning of the Trino workers to recycle memory, and also when we're doing upgrades. So our solution to resolve that, having the HA setup, is to do multi-cluster routing. Like I mentioned before, the Presto Gateway service, it was open sourced by Lyft. And we are using that to act as a central proxy to direct the queries to different Trino clusters. But there are several concepts. One is routing group. So routing group, there can be one routing group for each purpose. For example, ad hoc usage or PI usage or financial usage, etc. And each routing group can have multiple backend Presto clusters. This means here it means the physical Trino clusters in the backend. So the way it works is users will submit a query to the query gateway, and the gateway will, behind the scene, it periodically pulls the cluster usage, the usage of all the backend clusters for each particular routing group, and then do the load balancing against the usage metrics it collects. So there can be two. There are two metrics we have been using. One is number of queries running on each cluster. The other is average reserved memory per worker on each cluster. So we were using that to determine which cluster to route the query to. And the other one note here is that we are routing based on a weight distribution instead of naively saying that, hey, I see this cluster 1 has the less number of queries running, so I just redirected the next 100 queries all to that cluster. So we are doing that to avoid, avoid routing all the queries to one cluster during the traffic surge. To give you an example, how we do that is, let's say we have 3 ad hoc Trino clusters. One memory usage, average memory usage per worker are 200, 100, and 300. And then we calculate the corresponding routing weight based on based on how much memory it's using now. And the higher memory it currently uses, the lower the lower weight it will get for routing the next query. So yeah, so it all adds up to 600 GB. So this is 3, this is going to be 6, and this is going to be 2, and then it calculates the weight. Yeah, so as we're seeing here, because ad hoc 2 only has 100 GB usage, so it will get the largest weight for getting the largest weight for getting the next query. So this is basically a graph of showing how this routing group and weight-based routing works. So finally, I'm going to talk about migrating the Trino clusters to Kubernetes. So problems with the current EC2. So currently the Trino clusters are all running on the bare metal EC2 machines, which is causing a lot of operational overhead. Reasons are, firstly, we need to deal with 2 sets of operational tools. One is Terraform. So we use Terraform for maintaining all the AWS states. And then, which means whenever we need to create a new cluster, we will need to set up ASG, launch templates, IAM roles, security groups, all the stuff. It will be in Terraform, and it takes a long time to build those up, even with some templates. And once that is finished, all those resources have been provisioned. Then we need to use SaltStack, which is another orchestration tool we're using internally to push all the Trino setups to the EC2 bare metal instances, like downloading the binary, spinning up the process, and installing all the dependencies, stuff like those. And also, so managing these two sets of operational tools is always a headache. We basically need to manually record all the steps, like we should do this first and do that first. If we are missing some step, then the cluster will not go up. And also, it takes 10 minutes to provision a Trino worker instance from scratch. This is when like upscaling happens, auto upscaling happens. It will take 10 minutes to fully bring up a bare metal instance into a running Trino worker. And this is a bit too long for us. And also, like I mentioned, there are a million steps to create a new cluster, even with the templates on both Terraform and SaltStack. And actually, there is another issue I haven't mentioned here, is that currently Trino is iterating very fast. So if we want to keep up with the latest version, then it's going to be deployment happening very frequently. And our current EC2 setup does not. It's very hard to support that. So the solution is basically to migrate the Trino clusters from EC2 to Kubernetes. This is the sort of a design graph of how will it look like when we migrate Trino to Kubernetes. So basically, the upper layer are the clients we have, and we have already migrated Query Gateway to our Kubernetes cluster. We just need to migrate this blue part, the EC2 part, to Kubernetes. And with each Kubernetes node running a singleton pod for the worker, because Trino is actually occupying a lot of resources. We don't want to mix Trino worker with other types of services. So like I mentioned, we have ongoing effort to migrate Trino clusters to Kubernetes, and to reduce the operational overhead, we will customize our a CRD. It's a Kubernetes concept of customized resource definition, basically to centralize all the Trino components in one Kubernetes manifest, so that we just centralize changes in one place, and then whenever we made that, we made some change, we just call Kubernetes to auto deploy that. So the components are one coordinator, a certain number of workers, and a horizontal pod autoscaler, which helps with the autoscaling. And we embed the graceful termination as a script to the pre-stop step for workers whenever we want to trigger a worker shutdown or downscaling. And there will be also registration and deregistration to Query Gateway as a pre-start step for the coordinator when it spins up. And the other benefits that Kubernetes offers us is that we basically have a dedicated team manage the Kubernetes clusters. So we asked them, they said it's relatively easy to have multiple instance types in the Kubernetes cluster. So we can basically just try different instance type for different types of queries easily. And yeah, that's all I have.
That's awesome, Yishuan. Very amazing what you're doing there. First question from myself. You're not doing this all by yourself, are you? That sounds like a lot of work. So what's the team at Robinhood? Like, it's you, and you said there's a Kubernetes team. Who's helping you?
Yeah, so we have so I'm in our data infrastructure team, and we have currently I think it's 8 members in our team. That we, of course, we are not only managing Trino, but we are also managing our Hadoop clusters. But yeah, Trino is our central data query platform that we're maintaining. So I'm not on my own for sure.
Yeah, that's amazing. So you also have to interact a lot with your customers. Like, I'm guessing you were mentioning earlier that lots of people are using Looker and other query tools. Do you support them, like in terms of the data model and whatever is in your S3 storage?
Yeah, that's a good question. So we are mainly supporting the infra related questions. But for Looker, we will have a dedicated Looker team to handle upstream client questions. We just we collaborate with the Looker and Alasian teams to to set up how Looker communicates to Trino.
Okay.
And then we will also hop into answering some of the Trino related questions, like what if like query fails due to memory issues, stuff like those.
Mm-hmm. Is there a lot of like collaboration happening between you and those teams in terms of query performance and stuff like that, or that generally just happy how fast Trino is?
We actually it happened not that frequently. We are we will help with if there are critical queries that have to happen in a certain time, it arrows out, we will definitely help them, increase the cluster resource or help them debug what could be, to fix, to raise the performance.
Cool. Need to feel free to jump in if you have any questions. Let's see what others have.
Yeah. Sorry, I was just curious, Ishwan. Like, I know you mentioned like Looker, connecting S3 because of the federation use case in Trino, like that capability. Do you think is that something that you guys are looking in, like just enabling your data users to tap into different sources?
You mean something like doing access control?
Something like apart from S3, if they want to tap into other sources.
Oh yeah. Other data sources. I actually mentioned in my
you mentioned Pinot, so that's coming. That's pretty interesting.
Yeah, Pinot. We have use case for Google Sheets. I was kind of surprised that Trino can query Google Sheets, but yeah, it actually
it's kind
worked.
of a hack.
Yeah, and RDS instances. Basically, I think Postgres or MySQL tables. Yeah,
that's cool. And just to explain also to custom or to users that don't know what federated queries are, that basically allows you to write one SQL statement that talks to like Pinot and S3 and like whatever else at the same time. So you can have a logical connection in a join or whatever between data in your log files from your shopping system and whatever else, right? Like, so you can build really interesting use cases on that, and Trino can manage that nicely.
Adding to that, so the reason we are integrating Trino with Apache Pinot, one of the reasons is we want to have a unified entry point, right? But the other reason is Pinot itself doesn't support join. So if we want, if our business, our customers wanted to join some Pinot data, they'll have to rely on some other sources. Like I know Trino has a very good integration. I think it was built by Uber. With Pinot, they are working working very well. So that's another reason we are integrating Trino with.
Yeah, we're working closely. Like we had a Trino community broadcast with the Pinot team quite a while ago, but there's an active collaboration happening. So if you're interested in that as a viewer of this thing, check out the old Trino community broadcast about Pinot. And there's pretty regularly new changes going in for that. That's cool. With regards to regular changes, Ishwan also mentioned that you are on Trino, so you're on Trino 351, and you mentioned that we are going pretty fast. We are now at like weekly releases, and obviously that seems to cause a bit of anxiety of having to upgrade all the time. That's of course not necessary, but we do just have lots of new features all the time. So how often do you think you end up upgrading at this stage? 351 is, I don't know, like a couple of months at least ago, probably sometime last year, middle of last year or so.
Good question. I think maybe, a couple of months ago, or I don't remember the exact date actually. But I mean, like you mentioned, like since it's upgrading more frequently and having like more and more features, we definitely need to upgrade a lot more frequently. The current setback is that on EC2, it's relatively hard for us to do that. I've also just mentioned that we have much operational overheads to do that. That's one of the reasons we are migrating to Kubernetes. And I think with Kubernetes, with the much easier way of doing CI/CDs, then we will definitely upgrade more often.
Yeah, that's sounds very feasible. That's our experience as well. So Starburst Galaxy, for example, is using all Kubernetes, so that's cool. Wanted to ask another question related to your EC2 instances. Those are obviously very large instances. And that makes sense, right? Like for normal users that don't understand how this works, it's still completely paralyzed because you have just running a massive Java virtual machine on these big machines and then lots of threads internally paralyze. But with regards to the hardware, have you played around with using Graviton instances as well, or you're just sticking to the normal EC2 instances at the moment?
We just have the normal ones for now. Okay. Yeah, I think again, one of the setback is the current EC2 infra setup we have is very unfriendly to try new things, try new instance types. But yeah, definitely like with Kubernetes, I think we can definitely try different things.
Cool. Let's switch to a question from our audience. So Nick is asking, do you have any feedback loop from training clusters back to the gateway to help balance the queries, like the weight routing basically differently if one cluster is busy?
You have any feedback?
I think the weight routing calculation automatically does that, right?
Yeah, so we are not... So we have 7 Trino clusters for now. It's basically I think we're polling the usage metrics every minute or every half minute. I forgot to collect the usage data. It's not happening in real time, but I think that half minute or 1 minute is good enough for us to to balance the traffic.
Yeah, that's cool. Another question we had is from Shrivera. He's asking about average response times for your queries and the number of rows in your Hadoop cluster sort of data. You had some pretty amazing numbers in one of your earlier slides about like how much data is being pulled and how many queries are run. So I guess that goes into that realm.
Average response time meaning like
until the first result set is returned back to a BI user, right? Like it'll obviously depend a lot on the individual queries, but
yeah, that's actually a good question. I would say like for different use cases like Looker, so it basically just try to pull all the results. Actually, Looker have a default limit number of 5,000 rows, I think. So it won't return the result until it gets this 5,000 records. So that's not actually showing the average response time. The other type of use cases, like Presto Presto queries using our own Python client, I actually never did that average response time calculation. That's actually something we can analyze in the future. But I think it's pretty fast because the query analysis I just showed, like 93% of the use cases queries are finishing within 1 minute. So the response time should be fast.
So it's very much the like interactive analytics and like use case where people like run a dashboard, a query, and they get results. They don't have to walk away for coffee, at least. They just like get the results pretty quickly.
Yes.
Cool.
The number of rows in the Hadoop server, it's a bit hard to answer this. We really have I don't know, tens of thousands of data sets. So some of those are Some of the data sets have like hundreds of columns, and some of those only have several. So it totally depends on that, I think. So yeah.
Yeah, that makes sense. I have another question since we're talking about Hadoop as well. So I'm guessing that all your Hadoop storage is on S3 in Amazon, and your clusters are also in S3. Sorry, in EC2. But are they distributed across multiple regions or something like that, or is everything like literally in one AWS region and all packed together?
So we do have currently, it depends on the use case. I think currently we do have all the Presto clusters in one region for now. It's again depending on the traffic patterns, right? So our data mostly stayed in the S3 buckets. S3 doesn't actually classify by region, but currently our setup is around one region because it's good enough for our for the latency requirements and for our use cases for now.
Yeah, it's better for that anyway, right? Like once you start getting cross-region,
Yeah.
you have like cross-region traffic and like charges and stuff like that. But I was just wondering if you have international distribution of your data where like the data just sits over in, I don't know, somewhere in Asia or in Australia or wherever in the world, right? So it's all centralized at the moment. That's cool.
Yeah, again, depending on the use case, we centralizing those infra currently works best for us. So.
Okay, cool. Very interesting. Now, another question, you said before you have 7 different clusters or something like that at the moment, but they are all using the same hardware at the moment. Is that correct?
Yes.
So going forward, you also mentioned you wanted to go towards having different instance types. So what you would do is you would have the same instance type in a specific cluster, but then whatever that is tuned more to the use case of that specific cluster. Is that what you want to do?
Exactly. Yes.
Yeah. Okay, cool. So you would have like, I don't know, like a cluster that is more memory intensive with memory heavy nodes and one that's more compute performance.
Yeah. Yes.
That's going to be interesting to analyze and decide. To some degree, it's going to be let's play around and see what happens, right?
Yeah, definitely. We will again do the same sort of benchmark runs and see how it goes. Like if we see 2 instance type with the same amount of CPU, but one with less memory, and we submit the queries and they run at about the same performance, then we definitely will choose the one with less memory because it's more cost efficient.
Cool. Yeah, it's always a balance, right? Like you want to get as much bang for your buck, but you don't have unlimited bucks there either.
Yeah, right.
Cool. Nito, any other questions?
I mean, I'm always curious about, the different use cases, right? So I know reporting is definitely one of them. What about the other data users, like the data scientists who want to do like data discovery in S3? Are you guys even doing that with Trino, or is there like a different technology being used for that?
It's again upon their use cases. Like some, I think, I think whenever they want to explore something, they will be running queries against Trino because that's much easier, right?
Yeah.
So, but if they really want to do some very complicated machine learning algorithms and want the job to be more stateful, I would say stateful could be the word. Then they will maybe switch to Spark for running this large batch jobs to do that. So there are really different use cases, like because Trino or Presto, whatever. It is designed for running interactive queries, not the highly stateful high batch long running stateful queries. So totally depend on use cases. Like definitely they will be exploring the data using Trino as well.
Got it.
Cool. Well, I can invite you to test out Trino once you go upgrading to newer versions and have all that in place. You can try and play around with the fault-tolerant execution that Trino introduced in some of the recent releases in our project tardigrade, and then it'll be more suitable for ETL and batch workloads. So,
oh, nice. That sounds good.
Yeah, it's brand new, and we just got it across the finish line for first testing. Anyone out there in the community who wants to play with that, please do reach out on Slack to the Project Tardigrade channel. Check out the documentation. It's available under fault-tolerant execution, and we would love your feedback and see how that goes, right? Awesome.
Sure,
well,
sure, I'd love to. Yeah.
So as a last call out to everyone, don't forget to fill out this form to get your free Trino t-shirt. And again, thank you very much to everyone for joining us. If there's no more questions, I think we can wrap it up and let other viewers watch this in a delay on YouTube whenever they are available and have time.
Absolutely. Thank you so much for joining us, Yuchuan. Really appreciate it.
Yeah, very interesting. Thank you. Okay. Bye, everyone.
Bye. Thank you. Thank you, too, I'm afraid.